In this problem, I'm asking you to evaluate the trig functions at 45 degrees. And what is actually the question asking you to do? It is asking you to construct a triangle and analyze the sides of it when the angle that you constructed has a 45-degree acute angle. So every time that they're asking you to evaluate any trigonometric function, here's my trigonometric functions. You can see them right here. Sine, cosine, tangent, cosecant, secant, and tangent. We pretty much were saying, give me the values for those x and y coordinate points. Remember, I told you that as we're rotating, we're forming x, y coordinate points along, and each x, we're going to call it the cosine value, and we're going to call this the sine value. So essentially, I'm asking you for the values, the coordinate values. That's all it is. Nothing scary at all. So the question is, what are the values of 45 degrees? And now the first question that I asked you before we even begin, what are 45 degrees in radians in 10 seconds? What is it? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Figure it out? No? Maybe, hopefully. Well, let's remember what we learned in the previous section. We learned in degrees, right? We have a straight angle of 180 degrees. In total, it is equal to pi, right? And now we say, well, what is 90 degrees only then? Well, if the entire thing is pi from here to here, it must be that from here to here, it's only pi over 2. So 90 degrees belongs to pi over 2. Remember, it's equivalent in radians. Now, if 90 degrees is pi over 2, well, what is 45 degrees? Well, if this whole rotation in radians is pi over 2, if we're only going to 45 degrees, it must mean that this is pi over 4. So what is 45 degrees in radians? Is equal to pi over 4 radians. Remember that it is key, 100% useful. You're going to need it. Alrighty, so let's do them. What is sine of 45 degrees? Well, sine of 45 degrees. How do we begin this? Well, we generalize. Remember, size does not matter. It's just so we focus on the unit circle. It's the most basic one that we can play with. You don't want to be squaring and taking hypotenuse and square roots of other numbers. Why? We could if we wanted to, but why deal with all that crazy stuff when we can just deal with a unit of 1? Remember that circle inside that big circle? All the other big circles and big triangles are just going to be scalar multiples of this original baby. So let's work with this one. So when we're 45 degrees, well, it is a right triangle. If we form a right triangle, here we have it. So what must be true? It must be true that the Pythagorean theorem applies to it. So what it is, 1a squared plus b squared is equal to c squared. We need to understand what value this is. Well, 1 squared plus 1 squared is equal to 2, and that is equal to c squared. It must mean that c is equal to square root of 2. So square root of 2. So essentially they're asking what is the coordinate here? Well, the coordinate is x and y, so it's 1 and 1. How much do we have to get to here? We're rotating along the circle. If we're starting here and we start rotating, the coordinate for this one is 1 comma 1. So now when they ask us essentially what is sine of 45 degrees, it's saying using this triangle that we just solved for, give me the ratios, give me the value of the ratios, evaluate the trigonometric function at 45 degrees. So remember what sine was equal to using our good old friend SOHCAHTOA. Sine is equal to opposite over hypotenuse. Well, again, I always go to my angle first, and then I go for my hypotenuse, opposite, and my adjacent. Hypotenuse, opposite, and this is my adjacent. So if they're asking for sine, that is equal to opposite over hypotenuse, which is equal to, what is the measurement of the opposite side? 1 over square root of 2. And this is considered not simplified. In the past, it was such a big deal that you couldn't have a radical in the denominator, and we say we need to rationalize it. So we say, okay, we can multiply by something that won't change its value, and that value will be 1. But this one needs to be cleverly disguised as square root of 2 over square root of 2. 1 times square root of 2 is just square root of 2 over square root of 2 times square root of 2 is just 2. So that is the value of that angle, essentially, for sine. What is cosine of 45? Well, cosine, looking at our good old friend, is adjacent over hypotenuse. Well, adjacent over hypotenuse is, again, 1 over square root of 2 times square root of 2 times square root of 2, and it's equal to square root of 2 over 2. Ta-da! What is tangent? Tangent of 45 degrees is the same thing as me saying tangent of pi over 4 radians. So what is tangent of pi over 4 radians using these ratios? Well, it was going to be opposite over adjacent. And what is the opposite? Well, according to this one, is opposite over adjacent, which is 1 over 1, which is 1. Those are the values at that particular angle. Ready for the amazing part? Well, what is the value of its reciprocal function? Well, sine of 45, cosecant of pi over 4. I could say 45 degrees as well. I could say pi over 4 radians. Well, it is the reciprocal. Well, what is the value of sine of 45 degrees? Well, it was square root of 2 over 2. Well, it must be 2 over root 2 then, if it's the reciprocal. But we run into the same problem, so we multiply by root 2, and we have 2 root 2 over, well, 2. And look at this. It's gone, and we just have square root of 2 over 1, I guess, if you really want. This one is the exact same case, square root of 2 over 1. And essentially, well, what is, cotangent? Look at that. So then it's here. Cotangent of 45 degrees. Well, if tangent is 1 over 1 and cotangent is the reciprocal function, so it must be also 1 over 1, which is 1. Ta-da. Evaluating trig functions of 30 degrees. 30 degrees by the same logic, by dividing those 180 degrees, which is pi degrees along the first and the second quadrant, we can find that pi over 6 is equivalent to 30 degrees. So let's evaluate the ratios for that. How do we justify this one? Well, imagine here's my circle. And my angle, my center is right here. This is my angle theta. And my angle theta, let's start by actually making this one of a length of 2. And this one, this is the radius, is a length of 2. And look at the beauty of this. If this is sine of 30 degrees, well, let's talk about what happens at 60 degrees. If we say that this is 60 degrees, we can do that. And this is perpendicular to that one. Well, what was this then? If it was an equilateral triangle, then this becomes 1 and 1. So, ready? When we're talking about 30 degrees, Mr. Perez, why do we use 60 degrees? Because then using this reasoning, we can actually focus on this baby right here, the one that is only 30 degrees. And what is 30 degrees? Well, this is going to be 2. Sorry, I drew it wrong. It's the other way. There you go. Right? Is 90 degrees. That's 30. This is 2 and this is 1. So what do we know? In relation to theta, we know the hypotenuse. This is always the hypotenuse opposite to the 90 degree. We know one of the sides. We're going to need to find what is the other side. Using Pythagorean theorem, we also find that this is equal to square root of 3. So now, if you're like, Mr. Perez, I don't know how to picture that. It's okay. You can just picture it like this. Flip it. Or you can actually, in relation to this one, you don't need to flip it. This is the, again, this is the hypotenuse always. This is the opposite. And then by process of elimination, this becomes the adjacent. And just follow those ratios for that. So we can see the sine of 30 degrees is opposite over hypotenuse, which turns out to be 1/2. Cosine of 30 degrees is the same as me saying cosine of pi over 6, which is equal to square root of 3 over 2. Remember, adjacent over hypotenuse, square root of 3 over 2. And then lastly, tangent opposite over adjacent, 1 over square root of 3. We rationalize square root of 3, which is equal to square root of 3 over 3. Ta-da! And then we can easily find the reciprocal. So cosecant of 30 degrees is equal to 2 over 1, which is just 2. Then we have secant of pi over 6. This is equal to hypotenuse over adjacent, which is 2 over root 3. By rationalizing, we end up the multiply by root 3, multiply by root 3, and this is equal to 2 root 3 over 3. That one does not simplify. And then lastly, if tangent of 30 degrees was square root of 3 over 3, it must mean that cotangent of 30 degrees, the ratio for that is 3 over root 3, rationalize, 3 root 3 over 3, the 3 is divided out and is equal to root 3 over 1. Ta-da! Those are the ratios for that. So each of the 6 can be paired to another one that is the reciprocal. That is important to understand, and we're going to be using all of them. One trick to remember, Mr. Perez, I have such a hard time remembering what is sine and remembering that cosecant is the opposite. I kind of want to say secant. Well, no, the trick that Mr. Perez uses is no two c's together. No two S's the same. What does that mean? Well, I always know that tangent, the reciprocal, I always know that it's going to be cotangent. Nothing too like fancy or complicated about that. It's when I start questioning what is the reciprocal of sine. Is it secant or is it cosecant? Well, then I know it's going to be either secant or cosecant. I need to know that. That's the first step. But then how do you decide which one is which one? It's, well, if I'm finding the reciprocal of sine, I know that not two S's should be together. So that means that it cannot be secant. So I use cosecant. That is the little method that I've always used. When it comes to choosing for cosine, well, what is the reciprocal of cosine? Well, again, I better know that it's going to be either a cosecant or a secant. But following my rule of not two c's together, not two s's the same, must mean that I cannot be cosecant. So it needs to be secant. That's how I remember it. And I don't know. I kind of like my logic there a little bit. Hey, I don't know. Let's move on to the next one. I think here's a nice pause. And let's actually do a new video for that problem. Ta-da! How do I do this? Oh, here. I cannot delete. Let's see.